Hello, this is Dr. Gibson. Welcome to our latest video for the week, chi-squared and other non-parametric tests. So our highlights or our main points for this time are two types of chi-square tests. Then we'll talk about non-parametric tests, and then what to do if your data is not normally distributed. And last, we're going to look back at a few things from our linear regression tests that we did last week. So there are two types of chi-square tests. It depends on the number of variables you have. So the first one is called a goodness of fit test, and it's for use in a situation where you've got one variable, although there'll be multiple categories. The second type is test for independence. It's two variables, each with multiple categories. All right, so the chi-square tests work with nominal data. They can work with other types, but it's generally nominal. And that's where you get, they'll have categories because they're nominal. All right, for non-parametric tests in general, non-parametric statistical tests are methods of statistical analysis that make no assumptions about the distribution of the data being studied. They are sometimes referred to as distribution-free tests. All right? So the test that we've gone over, chi-square is the only one that is considered non-parametric. Non-parametric tests do have an advantage in that they have fewer requirements that must be met by the data in order to work. The disadvantage of non-parametric tests, and the reason that parametric tests are preferred when they can be used, is that they generally provide less information than parametric tests. All right. So what do you do if your data is not normally distributed? Well, at this point, you can't use one of the parametric tests, right? You may be able to find one that, if your data does follow a known distribution, you may be able to find one that fits that distribution. That would be a non-standard thing, but that's not bad. Often, though, your backup, or what's usually going to happen, is that your data is not following any known distribution, at which point you want to see if there is a non-parametric test that will work for what you are trying to test. SPSS will run the calculations for several different types of non-parametric tests. You may have noticed as we went through that each of the chapters we did in the Aldrich text had both a parametric test, which were the ones that we did, and an alternate test that was non-parametric. So one source of trying to figure out what test you might use would just be to open up the Aldrich text and see which one, which non-parametric test was matched up with the parametric one you were hoping to do. Like I said, there are a variety of them. You can find information out there. And many times the non-parametric one will work fine. You just have to find it. And if you find one, SPSS will probably run it. All right, looking back at last week's linear regression. Okay, so let's pull up the scatter plot. All right, so we see the scatter plot. Put the line in, the system ran the regression. You can see the points follow the line very well. Our data follows it quite closely. So what the scatter plot does is it both provides a visual check that the data fits the line, follows it, and for outliers, right? There really are no outliers this time. They're all the points are quite close to the line. Another thing about this test is we've got two new assumptions. In other words, two assumptions we haven't seen in any of our other tests. This first one is that the residuals are normally distributed. Okay, so this is going to be checked using what they call it as a normal PP plot. Okay, and the way that this works is if the residuals are normally distributed, these points should follow the line closely, and they obviously do, right? They follow it quite closely, so that worked. And then the second is that the data values follow a joint or called bivariate normal distribution. All right, so this is the next test down here. the points in the scatter plot versus the regression standardized residual appear to be random. Okay, so what's going to happen with this one, is that this plot right here should look like there's no pattern, right? So they're just scattered, and if they did follow a line, it's a horizontal line straight across. That is an indicator of a random scatter, which is what we wanted, right? What this is designed to do is yield a random scatter if the variables were, as we hoped, following a bivariate normal. All right. So those are our two new assumptions for this time and how they work. Our data did pass both of them, and then that capital R squared, which is the percentage difference between y values accounted for by differences in the x values. All right, so we've talked about that. And also, for a linear regression, it is what's used to measure the effect size. So the effect size is the R squared this time. All right. 1 week left in the class. At this point, all you have left is the final and getting ready for that final. I hope you've enjoyed the class.